Good afternoon, guys.
Good afternoon, sir.
In this session, you people are going to discuss about the case study on CMOS fabrication. Okay. What is meant by CMOS technology?
So CMOS is the complementary metal oxide connector, which was a basic functions of two types, NMOS and PMOS. It was used to manufacture the ICs. ICs are nothing but the connections of transistors, which was used to transfer signals into many.
Okay. Why we are using CMOS technology in VLSI?
Sir, it was very high speed and low
power
consumption speed.
And reduce space.
What is meant by pull-up network and pull-down network?
So pull-up network is connected to the VDD of the circuit, sir, and the pull-down network is connected to the ground of the
In CMOS.
circuit. Yes.
Okay, please start.
So guys, today we are going to conduct a group discussion on CMOS fabrication. So first, CMOS is the complementary metal oxide semiconductor, which was widely used in IC designing. So ICs are nothing but the millions of transistors connected in these parallel transitions, which was used to transfer the signals. CMOS basically consist of two types, which are NMOS and PMOS. In CMOS fabrication, there are many steps. First of substrate preparation and oxidation, photolithography, etching process, and ion diffusing, and many other processes. They will be explained by our teams.
There are two types of process for the CMOS fabrication. The first one is the N-well process and P-well process. In the N-well process, the substrate will be, anyone can say what is the substrate in the N-well process?
Substrate will be P substrate is.
In the N-well process, the substrate is N and the diffuser is P-well. So in P-well process, the substrate will be P. Okay, then there are many processes. Will be first forming the substrate of the first layer. Then we'll be giving the SiO2 layer. Then we'll be proceeding with the photoresist layer. Then as he said, the photoresist layer, and then we'll be doing for the etching process and etc.
Then coming to third step, the third step is photolithography. Photolithography consists of three steps: etching, UV rays, and mask. First, etching process. We are etching the unwanted SiO2 layer in the CMOS fabrication, which is unwanted for the next step. This is etched by the applying of UV mask for the regions where we unwanted. For this, we are applying UV rays. Through UV rays, we can cut it and take it out. Then next, photoresist will be applied. Next, the doping process will be occurred. Then next step is following to the next step. The schematic view and the output was verified, and this moved to the next process of testing process.
And next, metallized process. The metallized process, building a whole circuit by using of UV rays, some other instrument, and we have connected into a circuit format. We are manufacturing a circuit by using a CMOS combinations. We are using in VLSI System Designs, and we have combined and combined within a circuit, and we even next step as in simulation step. We are simulating a VLSI simulations. We are using CMOS combined, and we are getting an output. You can working or not. We have input in the IC. We are using a million of transistors in the ICs. We build upon a millions of transistors using our VLSI system design process by CMOS combinations, and many applications are using many other process, many other places we can occupy, but and it can applicable. First process, we are using many other ICs, but we are using NAND gate. We have studied in digital labs. We have seen some ICs, NAND gate or any other, and we are using traffic signals and many other places. We are using laptop chips. We are increase our processor memory unit, and CMOS and PMOS will combine. The power consumption is very low. We have used to many other combinations. It will very reduce and very useful to we using in our chips or many other memory unit. And we are using mobile processor nowadays using a Snapdragon or a MediaTek Dimensity and many other processors using. Using high processor nowadays Snapdragon 8 Gen S. It is using a high model, high feature models. It is using combined with an VLSI system designs, and we are anybody says in VLSI. What is my VLSI?
Very large scale integration.
Yeah, and anybody says in by an IC. What is my IC?
Integrated chip.
It was used to transfer our message signals by using of millions of transistors just
Yeah.
connected.
Yeah, millions of transfer. We have increased transistor efficiency on chip on IC. It will be very efficient too. It can run very high performance. We are using nowadays. Processor RAM has been 1 TB, 2 TB, upon going many other processors, and we are using but in small size. When the mobile weights are under come from 150 grams. Before runs 1 kg, we come with weight is reducing by an VLSI chip designs. We are using a transistor. The transistor will combine upon a reducing of chips, reducing of spaces in controller, in microcontroller. And they mainly used in microcontroller. We have used in many other projects or many other areas. The microcontroller has come from VLSI chip designs. Used of CMOS and PMOS, we have combined many other circuits. We have reduced in space. All other circuits we can build in a VLSI design, system designs, and we can use in many other sensors. Sensors can implemented by a microcontroller. Both microcontroller and sensor will combine, and it will given some output projects created. It will be
Some
applicable.
of the microcontrollers were used as Arduino and ESP32 models used recently for
Raspberry Pi.
Yeah, Raspberry Pi. Many other microcontrollers are made up of millions of transistors and ICs to work the controller of same of as a project. So upon this, we are using fabric. Coming to fabric steps, first of substrate preparation. As like earlier said, the substrate preparation is the main process to create a base of the substrate of CMOS. And oxidation, SiO2. As you said, as SiO2 layer is a very important step, which was prevents from external disturbance like voltage distribution and any other temperatures or any other humidity activities. So upon the photolytic, it was used to cut the unwanted SiO2 layer, which was used for softening SiO2 layer. And etching process, it also, as you said, photolithography consists of etching and many other process. So etching is used to remove unwanted process. So after that, ion implementation. As you know, ion implementation is a very important in CMOS fabrication, which was used as a it can be used as a N surface and P surface of diffusing of N impurities and P impurities.
When we come up from an application state, we have said about an Raspberry Pi processor. It has a RIP processor. It is in very small. It's used as a micro level processor. By using Raspberry Pi processor, the VLSI design is very useful.
Advantage?
You not present the conclusion.
Conclusion.